Welcome back to the office. We want to continue taking a look at some examples for trigonometric substitution. And you might notice here that we've skipped over an example. If I scroll up here, this is going to be a supplemental example, so I'll record and post that later. We'll do an integral involving this particular form a little bit later that has integration bounds. So we'll use this as a supplemental. It's just more than we really need. So let's take a look at this example, an integral involving a squared minus u squared. So we have, u squared minus a squared. So we have x squared minus 25. Of course, 25 is 5 squared. So first, maybe you recognize that this is the integral of x squared times the square root of x squared minus 5 squared dx. And if we go back to what was suggested for us when we have u squared minus a squared, we want to let u be a times secant theta. So we want to let, see, u here is just x, so let x be equal to 5 secant theta. Then dx is equal to 5, let's see, derivative of secant is secant tangent, so secant theta, tangent theta d theta. And our integral itself is going to become the integral of, well, x is, oh, and that's a cubed, not a squared, so let's copy that correctly. The integral is x being cubed, so this is 5 secant theta being cubed times the square root of, making our substitution, it would be 5 squared secant squared theta minus 5 squared. Let's see here, and d theta is 5 secant theta tangent theta d theta. So there's quite a bit going on there. So first, our simplification, 5 cubed, I can pull that out, and actually I've got a factor of 5 here as well, so we'll call it 5 to the 4th secant cubed theta, and this is the square root of, right, once I recognize it as 5 squared times a secant squared theta minus 1, right? If I were to put parentheses around here, this would become a 1. If you want to think of it that way. But in our substitutions, we recognize that this is 5 squared times tangent squared theta. And then we have, let's see here, there's an additional factor of theta, so we can call this one to the 4th. And there is a tangent theta here as well, d theta. So 3 factors of 5, 4 factors of 5, 3 factors of secant, 4 factors of secant, and this thing becomes the square root of 5 squared, tangent squared. So when we square root 5 squared, we get 5. So this is 5 to the 5th power out in front, times the integral of secant to the 4th theta. And the square root of tangent squared is tangent. So tangent times tangent gives us tangent squared theta d theta. So this one is, let's see here, a little bit, right? You have to remember our trigonometric integral techniques. So this also requires a substitution. So we've done a trigonometric substitution to get to this point, right? We used trigonometry in the substitution, and now we have a trigonometric integral that we have techniques to evaluate, which also requires a substitution. And what was the recommendation here? Well, the recommendation, when we have, let's see here, an even number of secants, then we pull off 2 of those and use them as the derivative or the differential for letting u be tangent. So let's see here. What does that look like? Our recommendations is to let u be equal to tangent theta, and that gives us du is equal to secant squared theta, d theta. So that works out very nicely because we can turn the remaining factors of secant into tangent because there's an even number of factors of secant. So this allows us to perform our substitution here. maybe pull things off together. So 5 to the 5th power is 3,125. So times the integral of secant squared theta times tangent squared theta, and I'm pulling off the secant squared theta d theta just to help us out here a moment. So this is going to be 3,125 times the integral of. Now I don't want secant squared. I want to recognize that secant squared is equal to 1 plus tangent squared. Let's see here, double check that. Secant squared is 1 plus tangent. I knew I wrote that down somewhere. So we have 1 plus tangent squared theta, and then tangent squared theta, and secant squared theta d theta. So I've rewritten this so that way I can help see where all of my substitutions are occurring. So I haven't actually, of course, made my substitution yet. I've just rewritten things so that way I can perform my substitution. If you approach it a little bit differently, that's fine. So now we recall that this gives us 3,125 times the integral of, I let u be tangent, so this is 1 plus u squared times u squared du. Now it's just a polynomial. That's not so bad. So it's 3,125. Let's see here, times the integral of u squared plus u to the 4th du. So this is 3,125 times 1/3 u cubed plus 1/5 u to the 5th, and then don't forget our plus c at the end. So this looks good, and now we remember that we used u is tangent. So this is going to give us 3,125 times 1/3 tangent cubed theta plus 1/5 tangent to the 5th theta plus c. And we say to ourselves, all right, that's fantastic. Now that it's in terms of theta, I still got to get it back in terms of x. So we return back to the beginning and we say, all right, well, what did we do to get it in terms of trigonometric functions? We let x be 5 secant theta. So we draw our triangle to help us out again. Let's see, right triangle, here's theta, and we know that we have x is equal to 5 secant theta. Let me write that a little bit lower here. X is equal to 5 secant theta, which means that x divided by 5 is equal to secant theta. And we have to remember that secant theta, oh man, remembering our trigonometric identities here. So this is 1 over cosine. So this would be, instead of adjacent over hypotenuse, this would be hypotenuse over adjacent. So our adjacent value is 5, our hypotenuse value is x. And using that, what we get is this side should be the square root of x squared minus 5 squared, which is fantastic, right? That appears here. We should expect that. So we want the tangent, right? Tangent of this. So tangent would be opposite over adjacent. So this is 1/5 times that, right? This over 5, opposite over adjacent. So that is going to give us that this is equal to 3,125 times 1/3 times 1/5 of the square root of, this was x squared minus 25 cubed plus 1/5 times 1/5 times the tangent of theta, which we said was, well, the 1/5. Oh, and actually this should be cubed there as well. So this is, 1/5 times tangent, tangent is 1/5 times square root. Don't know why I'm having such a hard time with that right now. 25 to the 5th, and this is to the 5th as well, plus c, right? Because tangent is this thing over 5. Tangent is this thing over 5. It's being cubed here, so cube and cube. It's being raised to the 5th power here, so 5th power, 5th power. What does that give us? Well, what we can do is we can distribute this in. So 3,125 divided by 5 cubed. Oh, I got to think about that one here a minute. Let's see. That is going to give us 25, right? 5 squared, 25. So 25 over 3 times the square root of x squared minus 25 cubed. Plus, let's see here, this is 5 to the 5th, so divided by 5 to the 5th is going to cancel, and I'm left with 1/5 times the square root of x squared minus 25 to the 5th power plus c. Excellent. Let's see. Yep, I think that looks good. Doesn't quite match what I have in my notes, but I think my notes might be wrong. So 5 to the 5th. Yeah, I think that's good. All right. So I guess that's it for that example. Yeah. If you think I made a mistake or want to identify it, well, let me know. I'd be happy to, but that's definitely the right idea and the right process. So even if there's a wrong multiple there, we have no worries. So I'll see you guys back here in the office for another example in just a minute.